Around 4 billion people, almost two-thirds of world's population, experience severe water scarcity for at least 1 month each year. Over 2 billion people live in countries where water supply is inadequate. Half of the world's population could be living in areas facing water scarcity by as early as 2025. So, you might have been wondering, why have we decided to address this environmental problem and make a solution? Water vapor has significantly increased the global warming rates in the world. We plan to absorb the excess amount of water vapor from the atmosphere and convert it into a safe, usable form to be used for different purposes. The water vapor content percentage in the atmosphere averages about 0.4% of the total gases. However, it varies quite a lot depending on time and place and can be over 2% of the atmosphere under warm, humid conditions. Now, let's talk about disadvantages of high water vapor content in the atmosphere. Increasing atmospheric water vapor also amplifies the global water cycle. They contribute to making wetter regions wetter and drier regions drier. The more water vapor that air contains, the more energy it holds. This energy fuels intense storms, particularly over land. This results in more extreme weather events, but more evaporation from the land also dries soils out. When water from intense storms falls on hard, dry ground, it runs off into rivers and streams instead of damping the soil. This increases the risk of drought. In short, when atmospheric water vapor meets the increased levels of other greenhouse gases, it impacts the Earth's climate that is substantial. Water vapor accounts for about 97% of the total greenhouse warming of the planet.
The system pulls in ambient air from the surrounding environment. This air contains varying levels of humidity depending on factors like temperature and location. Before the air enters the system, it's passed through filters to remove dust particles and pollutants. This ensures that the water produced is clean and safe for consumption. The filtered air is then cooled to a temperature below its dew point. Cooling causes the air to lose its ability to hold moisture, leading to condensation of water vapor. The condensed air droplets are collected into a reservoir or holding tank. This is where the water accumulates and gets stored until it's ready for consumption. Although the water collected is already free from many impurities due to the filtration and condensation process, such as UV sterilization or carbon filtration, to ensure the water safety and quality for the consumers.
So, you might be wondering why our system is better than others, such as desalination. This is another method for obtaining fresh water from ocean or other water source by removing salt from water. I will be listing major points which states why our prototype is advantageous over desalination in certain scenarios. The first one we will talk about is energy efficiency. Air-to-water generators use less energy as compared to desalination process. Desalination process requires removal of salt from seawater, which requires high electrical energy, whereas air-to-water generators capture moisture from air, which use comparatively less amount of energy. The second one we will talk about is availability of water resource. Air is ubiquitous and even in arid regions, there is considerable amount of moisture in the air, meaning that air-to-water generators can be used in a wider scale as compared to desalination process, which can be carried out only in oceans. The third point we will talk about is water quality. Water extracted by air-to-water generators by moisture are likely to be less contaminated with impurities as compared to desalination, which can contain impurities in the form of salt. Lastly, I would like to talk about infrastructure. Air-to-water generators are generally small and portable than desalination plants, which requires extensive infrastructure and maintenance. This makes air-to-water generators a potential solution for disaster.
Now we will be connecting this to a hydroponic system, which is a method of growing plants without soil, using nutrient-rich water solution as a growing medium. In a hydroponic system, plant roots are directly exposed to this nutrient solution, allowing them to take up essential minerals and nutrients more effectively, as the proper amount of water and nutrients can be absorbed by the plants. The collected water will flow through the filtration system so that the water can be purified for use. The water will be enriched with nutrients and adjusted to the pH level needed by the plants, which is crucial for plant growth. The small seedlings with the roots will be submerged in water, with the water flowing through the container.
Drawbacks: cannot be used in dry regions as moisture levels would be very low. and therefore won't be effective in all the countries who face water scarcity problems. It may be expensive to set up initially but would be very sustainable in the long run.